Well, anyways, we saw three great presentations, a lot of great ideas. We talked about 360 manufacturing, certainly moving data out of the swamp, a lot of great insights in terms of deployment of some of these learning systems, cloud platforms. You must have a bunch of questions. I know I do. So does anybody have a question? Okay, great, thank you. And certainly take advantage of the wall right here.
Thank you. Thank you very much. My name is Chris Sanchez. I am with ABB, Control Systems Automation. And I have a couple of questions, actually. My first question is for William. You mentioned that there are some open communication standards already, and you mentioned OPC-UA, and you also mentioned MT Connect. What additional open standards do you think will be the building blocks for enabling cloud computing and data analysis? Because customers need to go back and take a look at their infrastructure and say, what do we support right now, and what is available, and do we need to make further investment in our installed infrastructure? And the second question is more geared towards Vijay and Joe regarding these pilot projects, or if you have already a cloud infrastructure and data analysis infrastructure, if you could share with us some of those pitfalls that you went through, right? I believe that it's always when we talk about, yes, you're gonna face some troubles, well, that seems kind of like an understatement, right? So if you could share some of those pitfalls, and if you had already some ideas regarding the return of investment timeline, because these are just some of the questions that executives are going to come back and say, okay, so how are we going to measure it, by when, and how are we going to do it, right? One, two, whatever you want to approach it.
Okay, sure. Yeah, so the standard space, the ones that we're right now working with are things like OPC-UA, MQTT for pub sub. So MQTT tends to be the way that you get your data into the cloud. So almost all, like Amazon, Azure IoT, they all use MQTT so that feed upward. OPC-UA also provides an information model as an abstraction, so a node set which provides sort of a foundation for other ontologies to sit on top of it. So MQTT sits on top, MT Connect sits on top of OPC-UA, and OPC-UA can then be put into MQTT. You can then also layer things on, like for packaging, PackML is probably the leading standard there. For things like solid model geometries and design, I would go with STEP, AP242 is the leader in that area. There's standards around PLCs. PLC Open is has been getting traction now for the information going out to the PLCs to be able to do the sort of an abstract programming of the PLCs. Those are kind of the main, so that you have to sort of look at standards as being layers. So you have at the bottom layer, you have like your pure communication, things like TCP, and of course the narrow waist of IP. And then as you go up the stack, you have communication protocols like even HTTP, like MT Connect Native uses HTTP and REST. And then on top of that, you have things like, you have OPC-UA, which has its own communication, along with security, has a very rich security model, and a way to be able to, in an organization of the information internally that's standardized. So then you can start laying on your ontological standards like MT Connect, PLC Open, which define the meaning and the context of the data, as well as units and other things along that line. So as you build these layers, you start to get more and more rich data. You solve your connectivity problem, so you have a standard way to be able to connect and communicate in a safe way to your machines. You have a standard way to be able to represent your information, and then a standard way to be able to have meaning of the data, so that nobody has to spend, I hear this all the time, I spent 3 to 6 months trying to figure out what this value meant. Was it, I think it's a temperature, was it Fahrenheit or Celsius? Is it, is the machine on or off? Sometimes it's 0, sometimes 1, we don't know. So basically, having standard vocabularies and across everything is really important. So think of it that way. I mean, I could go on with standards. There's a ton of them out there. People think that there's too many and there's too much overlap. Actually, each one usually provides some value add, and you have to kind of segment them properly.
Great talking about a layered approach. Vijay, you want to add to that, please? I think you
Sure.
probably have
I can probably take a hit on the second question, so you can add on. So a couple of questions you had. One was around the learning and experience, right? And the second one was around return of investments. How do you justify the return of investments? So learning and experience, well, the different things which come from, at different stages of what you're doing, right? The first thing that I would actually think about is think big, start small, and you need to start somewhere, because if you kind of create a long-term vision and you wait for actually achieving that long-term vision before really celebrating success, it doesn't work. So, and it's a journey. So you need to kind of take incremental small steps in towards trying to achieve that big vision that you have, and that's a kind of a plan and a roadmap that you need to kind of create, and that's digital all about, right? Number one. When it comes to technology, I would actually say think ecosystems and think how you can bring together niche technologies. And when you kind of when you think and plan your own infrastructure, kind of think about how am I going to really integrate all of these partner technologies in being able to create a seamless mashed up value to our customers. So it's not about me trying to create a kind of a big blob out there. So think about microservices, think about how do we actually have an integration platform which can help me kind of integrate. It's never going to be one solution. As much as we would want to kind of talk about standardization and technologies, when we actually go out, you're really going to have a varied set of technologies out there from different vendors following different standards and different technologies and frameworks, right? So you really need to talk about how am I going to kind of integrate all of these different technologies in terms of creating a value. Last but not the least, there are aspects of security, scalability. What I talked about covers aspects of flexibility and scalability. When it comes to security, start thinking security from day one. Security is not a by the way, right? But at the same time, be very practical about what you think in security. So these are some jargons which kind of get used. I mean, everyone says, "Hey, is your solution secure? Is data privacy taken care of? Is all of these different aspects taken care of?" But you need to kind of weigh these in terms of the business value that you're creating and the realities of the business that you are into. So you can very easily over-engineer your products, in which case you won't meet your return of investments. And in a lot of scenarios, if you don't kind of start thinking of this in advance, you'll end up in a situation where you can't really build it reactively. So these are some thoughts in terms of learnings. And when it comes to return of investments, again, as I said, think long, but start showing returns incrementally. It's not going to be big returns, and any organization needs to be serious about long-term investment and long-term returns if they want to get into digital transformation. It's not like you get into this journey today and you'll see your returns tomorrow. No, it's not going to happen that way. So any organization which needs to get into it needs to have a long-term vision of how they're going to change themselves and the industry. And when you build your return of investments, your initial return of investment will actually be a return of value in terms of what you're trying to create as fundamentals for the investments return that you're going to have in probably 5 years or 10 years down the line. So you need to kind of build a return of value for your organization in the first 5 years, which might not be quantitative or which might not be financial, if I can put it that way, but then build it into the financial benefits as you go forward. And that's what I would say from my experience. Sure, I'll add something to it.
So I'll start off with return on investment. So we picked something that was pretty easy because we've already proved to the organization that machine monitoring and understanding where faults are happening and where the opportunities are to improve, we've already kind of covered, and people get that. So the return on investment is really zero, right? Because all you're doing is getting information. You have to really act on it to go get the value. But it started costing us so much to get that information that this is basically a way to do it for a tenth the cost or whatever, and it can do those things. So that's what I would say there. And then the other part of it on the cloud and the what did we learn? We're learning right now, right? So this pilot is underway. We're a large corporation, and so Autology was ready to go like in March. We had to have sourcing involved and all that stuff, so we finally just got it going. But the whole point of it is to help us learn and understand what's it take to put an IoT device on the floor, what are those pitfalls, what do clouds look like, all those kind of things. And I think I mentioned we might be using this as a pilot case to look at other cloud providers or other things as well. So it gave us a great opportunity just to learn and really understand what's important to us. And probably the biggest one, as I was talking to my IT counterpart, is in IoT or industrial IoT, really it's the platform, right? And making sure that you can support all those devices and maintain them and all that kind of stuff. So you think about what it takes to maintain all the PLCs in your plant and all that firmware and multiply it by 100 and say, now, how are we going to manage that? So that platform is really what we're trying to figure out.
Thank you. We have another question over here. Why don't you-
Yeah. How do you migrate time series data out of process historians into the cloud? We have hundreds of process historians with compressed 1 second interval types of data. When you pull it out of the historian, it's got to be put into flat files or what? Could you explain how you deal with time series data?
Yeah, we usually don't use historians, so we stream data directly from the equipment directly into the cloud. MTConnect supports a store and forward buffer, so basically, even if we get disconnected, we can reconnect and then pick up where we left off, so we never miss a beat. But I would suggest if you do have a historian, you do have this data in some format, the first thing we do is we take the data and we ship it up to the cloud, and we have a component that we call the enrichment component, which is basically what I talked about there, where it does a contextualization. That will help to build your intervals. You can do things like delta compression. So if the value isn't changing, you have like let's say 1 second or half-second intervals of the same value. Compress those in and build a duration-based event.
So you replicate your own compression algorithm in the cloud?
Or I would put it into a normalized form in the cloud. I'd take it out of the historian, I'd normalize it to a standard format. So I'd create some standard around, or use a standard like MTConnect or whatever, I don't know what domain or whatever the domain is. But I would standardize the data into a common information model with common vocabulary for all the different pieces of equipment that you're collecting data from in your historian. And then push that stream of information into the cloud. I would stream it into the cloud. You could use something like MQTT to do sort of a direct push. So we usually deal with direct connectivity to the equipment because most of what we do is near real time. So what we're looking at is low latency, maybe anywhere between a few seconds to 500 milliseconds or so. So we're trying to stop things before things go wrong. So we're doing predictive analytics, we're doing, for maintenance, for other things, process, and I can give you a lot of stories. But the idea is to try to get that data, not sort of in a local place, but try to get it up into the cloud as quickly as possible.
So you take the raw data and move it in the cloud and then do the transformations on it to normalize it and so forth?
We normalize to MTConnect on the shop side. And then we ship that up into the cloud, and then we run it through our complex event processing and classification engine. That's our first step. And then we store it into the database. So our complex event processing engine and statistical analyzer creates what I was talking about before, those contextual intervals, because you need those contextual intervals to be able to then go on and apply the next layer of analytics, which then do the learning and understand, okay, what was happening during this period of time? Because I can't, until I've classified the time, until I understand what's happening within context, I can't start matching against my patterns. And so we have this cycle of analysis, which we then push into our long-term. We also bifurcate. We do both batch and speed. If you talk about Lambda architecture, so we do feedback as well as we store into huge data stores in the cloud. So basically, our historian is in the cloud because we have infinite storage there. By some definition of infinite, and we find it much more efficient, as well as we have a standards-based model that we keep in the cloud as well that we can share with partners or work with other companies to be able to then add their special sauce and analytics on top of us. And that helps because we haven't dealt with too many, we don't usually deal with a lot of historians ourselves. Yeah.
Yep.
So that'd be the first step I would do is just translate it and then stream it up using something like MQTT. Because the ingest engines are really powerful now, like Azure and AWS for doing that kind of stuff. Yeah, sure.
Yeah, one of the, excuse me, one of the widely discussed approaches is, and very trendy ones, is the edge processing. It's becoming a kind of holy grail of the reduction of data before they are coming to the cloud. What is your opinion? Because it seems like your strategy is slightly different than the edge processing or processing on the edge.
Yeah, we usually put things on the edge depending on determinism and latency are kind of our two first dimensions that we look at. So we'll take a look at a problem and say, okay, how fast does this response have to get back to the piece of equipment or to the operator to be able to stop something before something goes wrong or to change operational parameters so that we can fix problems in situ. So that's like number one. So that will be sort of our first analysis of when we want to do edge. We haven't done edge. We haven't found that so far bandwidth and information flow has been a limiting factor for us. If we did, we'd downsample because we do compression, we do delta compression, and we do other things. I mean, just by nature of even the standards do delta compression. But we haven't found that the information flow when compressed to the cloud has been a problem. So, I'm sure at some point it will be, but it is not. We tend to collect everything because when your data scientists want to start looking for causality, we find that the more information they have, the more data they have, the better they can do, because something that you may think is unimportant may not be. We do some downsampling of data for stats, like fast Fourier transforms and things along that line, for certain types of signal data that we're getting, but that's about the most we'll do for compression or for downsampling at this point.
Well, yeah, thank you. I do understand that the edge processing shouldn't be a panacea for everything. So it really depends case by case. And specifically vibration data probably shouldn't be coming in millisecond intervals into cloud because the storage does cost something.
Yeah.
So it's really difficult topic to decide, what data is to be pre-processed and reused or filtered or cleansed at the edge and what is coming straight to cloud, maybe through some compression algorithm. So not easy. Yeah, understand.
Yeah, and just want to add to what Bill said. I think it's a decision that you take during the modeling, right? To say what remains in the edge, because you don't need to kind of probably send everything across to the cloud too. And even when you send something across to the cloud, is it going to be processed information that you send across? Or are you going to send raw data, all the bytes in? So these are the kind of things that you probably do as a modeling when you actually know what the use case is and what needs to go and what needs to stay and where we do the actions. So that's a part of the modeling exercise to start with. There's never a scenario where everything goes to the cloud or everything stays at the edge or vice versa.
The only thing I would say on the solution I have is we're not going to send images of the stack light up to the cloud, right? We're doing that image processing at the edge or at that device, and it's just giving a digital representation of it. So that's where you would want some kind of horsepower there and not send images for that example.
Are there any additional questions? I think we're just about out of time. No? Okay. Well, are there any additional thoughts, or you'd like to put closure on with this session? We had a great session here, talked about a lot of things. All set?
Yeah. So Joe, since you acquired a dog food company, are you guys eating your own dog food?
Oh, no. Well, we'll leave it on that note.
Sorry. That was good, though.
All right, thank you very much. It was really great.